Okay, so I'm going to continue with the part one task. So in the first part, we did all of these. I mean, in the first video, we completed till creating our own custom dropout and the custom regularization. So I'm going to continue with these using callbacks and one hedge. So I'm going to continue with this. So let me open the collab. So this is where we are doing callbacks and TensorBoard. So it this particular collab demonstrates the use of Keras callbacks to monitor and manage the training of a neural network. We will also use the model checkpoint callback to save the best model weights during training. And then we'll also use the early stopping callback to prevent overfitting and TensorBoard to visualize the training metrics, model graphs, and also everything else in the interface. So basically taking all of it, doing data setting the data set, splitting the model, defining the model, and then defining the callbacks. So we're defining the checkpoint over here. This is for the early stopping. Then we also have the TensorBoard to log the metrics, training, testing, checking, everything. So this is where we're gonna run. So accuracy improved from because in the beginning we don't have anything, so it'll just be as minus infinity 0.737296, and then after that it did in the epoch 8 it did not improve, and then epoch 9 it improved, and then till epoch 12 it didn't improve. uh, so basically it'll keep on testing, and then after epoch 18 we got 0.9778, and then this will be saved as the best model. But after that we checked for a few epochs, it didn't improve. So we did the early stopping over here because it didn't improve anywhere, and we taking restoring model weights from the end of the best epoch. So we're taking that. This is the accuracy, and then after that we did the model running, and so this is how I was able to look at the logs too. This is the early stopping and also the callback, and then this is how I was able to look at the logs. I won't be able to open this now because it I didn't run it now, it already ran. But so when you give this, it'll give you a link to open, and then the TensorBoard thing will be launched at this particular URL. So yeah, that is all about uh, callbacks and using TensorBoard for visualizations. And then the next one I'm going to look at explain through is using Keras Tuner. So this is for hyperparameter optimization. So this is why we use the Keras Tuner. Let me open the collab now. So this is we'll have to first install that. So basically Keras Tuner is used to automate the process of hyperparameter optimization for a neural network. We will define a search space for the number of units in a dense layer and the learning rate, and then Keras Tuner will try to it'll try different combinations of these hyperparameters, training models, and evaluate their performance to find the optimal configuration for all of the values. Doing everything, yeah, setting optimizer, everything is done. um, so this is how we're defining the model, or like basically building the model. We have the data set, the data set, splitting of the data, and then this is where we get the tuner. This is where the tuner comes into picture, and the number of different hyperparameters to try, we are setting it as 10, and the number of executions that we want per trial is 2, and then we're going to display the search space, perform the hyperparameters search, and then this is how we're going to get the best hyperparameters. And then based on these hyperparameters we'll be able to uh, run the model, like fit the model. So as you can see, this accuracy is uh, after the 10 trials, and then best accuracy we got 0.98, and then so these are the best hyperparameters that we found with the highest accuracy. So units 1, this is the RMS prop, and then this is learning rate, and then we're running 57 epochs, and then after all of the epochs are run, you can see that we got 100% accuracy. We started from 0.5251, but then we came up with high 100% accuracy because of the hyperparameters that we were able to configure. So that means that this Keras tuner worked really well and we were able to get the best accuracy. So that is all about using the Keras tuner to find the best hyperparameters that we can define for a model. And then we have the next part where we're doing the KerasCV data augmentation, and this is nothing but it is how to use like data augmentation layers that are provided by the KerasCV. So use of KerasCV library for performing data augmentation on images within a TensorFlow Keras environment. So let's start with that. We're just getting KerasCV again, updating it again, then taking the dataset. We're taking the CIFAR dataset, CIFAR10 dataset over here, and then taking the images because we're working on image library, that is why we took that. Then these are the different augmentation layers that we have, and then we're applying the augmentation layers and visualization is done on that. And then we're doing the KerasCV. We are integrating KerasCV augmentation into the model. So as you can see, this is the augmentation that is done. So these are the different functionalities that we're doing: random flip, random rotation, random zoom, random contrast, random translation, and random shear. So we can see that all of these are applied on the images, including flipping, rotation. You can see all of that is also done. Rotation, flipping, everything is done. So this KerasCV, we can say that it offers a convenient and powerful set of tools for performing image data augmentation with TensorFlow. So this is all about that. Uh, this is data augmentation. So let us go to the K part. We're doing data augmentation for multiple data types. So the same thing as before, but we're using multiple data types like time series, image, video, text, etc. Doing all of the downloads that we required, and then loading the CIFR dataset, and then the one hot encode labels, building the model. This is without the augmentation, and then on that we're doing the augmentation. So with visualization of the augmentation is also done. So as you can see, this is the um, so you can see that with augmentation there was slightly in improvement in the accuracy. And then this is image data augmentation using KerasCV. Same thing, splitting and then defining the KerasCV augmentation layers, applying and visualization of that. And then here we're just creating a simple CNN model to do that. So as before, this is what it is giving: augmented images. And then this is for the video. So we're taking the video and then we're doing the augmentation based on that. And then this is for the text data. This is basically for video and we have two for images. So as you can see, with augmentation we got 0.69 as the accuracy. This is for the text data augmentation and classification. So we just have a few sample texts and we're doing the text augmentation here. This is for the TF IDF vectorization, which is nothing but the feature extraction what we're doing. And then so let's see, let's augment some text data, let's augment some school book information. So we got the text classification accuracy with augmentation as 100%, which is really good. So we can say it is working best over here. And then we have the time series data augmentation and classification. We're taking some time series data over here, and then we're just creating some noise in that particular data, and then we're doing all of the uh, we're doing everything here, creating the classifier model and everything. So as you can see, this is the original data, and you can see that the augmented data is very close. So we got 60% accuracy, which is good. And then the last thing, I think the last thing we're doing it uh, data augmentation is on tabular data. So we're just generating a fake tabular data and defining the number of samples, everything. testing, splitting everything, and then adding small noise to check the accuracy. So after that, doing that model training, testing, everything is done. So as you can see, we got around 50% accuracy for the tabular data augmentation. And then after that, we have the speech data augmentation, where we're doing the same thing. We're generating synthetic data and then we're applying speech data augmentation to that. And then this is the original spectrogram of the data, and this is the augmented one. And the accuracy we got again is 60%, which is good. And then this is the document images data augmentation and classification. So we're just doing the same thing where we're generating synthetic data, and then we are zipping the test tree and everything, and then after that we are checking the original document image and then the augmented document image. You can see that the accuracy is best, and we got a percentage of about 80%. So yeah, this is all about the results that we have. Okay, let's go to the next part where we're doing fast AI data augmentation. So this collab, it's nothing but it's for displaying the capabilities of the fast AI library. So the first thing we have to do is installation of fast AI. I'm importing everything, getting the data from that, and then doing the importing, getting the data set here, loading data from train or valid folders, and then show augmented data. So this is the data set that we have, and then data enloader, class labels, plot the images. So you can see that all of this is done. All of this is using the FastAI library, and then we're creating the model for this. We're creating a model defining epoch, CNN learner classification, plotting a confusion matrix. Everything is done. As you can see, we started with 91% accuracy and we ended up with 99.5, which is great. This is a confusion matrix, and then here we have the prediction, action, loss, and probability. So yeah, this is about using the fast AI data augmentation for uh, classification and augmentation on the digits data set. Sorry, the MNIST data set. So yeah, this is all about the part one. And in the next video, I'll have advanced Keras deep learning constructs. So yeah.